Now we're going to talk about the domain and range of functions, and they're just, two different sides of the same coin. The domain of a function, and all this is spelled out in my book, and the domain of a function is the collection of all the input values. In other words, what are all the x's that you can plug into a function? And that defines the domain. So to give you an example of this, here is a half circle. And it has a radius of 2. Now this half circle is a true function because it would pass the vertical line test, but it has a start and a stop point to it. And if you're interested, the function y or f of x would be the square root of 4 minus x squared. So if you were to take this in the y form and square both sides and then collect the terms together, it'll be x squared plus y squared equals to 4, which is the equation of a circle. But when I write it with the square root function, square root is always positive, and I think we've talked about this before. And so actually in this form it only represents the top half, which is makes it a function. All right, well, in any event, the domain stretches from -2 to +2. And so we would say the domain is the set of all the x's contained in the interval between -2 and 2, inclusive. So I wrote this in interval notation, which you should have learned earlier, and domain stretches from -2 to 2, including the endpoints. And now I wrote this down from the graph because the graph shows where this function is, where it lies in the plane. If you were to look at this algebraically and think about it, you say, well, okay, in terms of graphing on the xy plane, I can't have the square root of a negative. Now I realize we talked about square roots of negatives in terms of complex numbers, but when we're talking about graphing in the xy plane, then we're only interested in the real numbers, not the complex numbers. So that's sort of implied here in this section. Domain is only with real numbers. So what numbers can you plug into here and get a real numbered output? Well, if you made x larger than 2, then 4 minus that number squared turns out to be negative. So 2 is the largest number you can fit here. That will give you 0. And -2 is the largest negative number you can put in there. So it fits in between there. But graphically, it's just easier to look at and say, okay, the domain goes from -2 to 2. Now, as long as I have this up here, let's talk about the range of this function. So the range is this part. In other words, what are all the output values? The output values lie between 0 and 2. And so the set of all outputs is called a range. So if you want to learn it this way, domain and range, alphabetical order, domain comes first. That's a set of x's. Range comes second. That's a set of y's. Inputs, outputs. Inputs and outputs is also in alphabetical order. So, it's a little trick you can use maybe to keep this straight. But the range for this function would be all the x's, all the y's that lie between 0 and 2, inclusive. And so, again, I use interval notation. So that tells us where the boundaries of our function lie. And the boundaries are in the x direction and in the y directions, in terms of domain and range. So I'm going to erase the board and give you another example of this. Here's a function that I've encountered before, and actually the true function I've encountered also, I think comes out on the left side of the graph as well, but I'm only going to think about the right half here. And I kind of call it the Nike swoosh function. This is not quite as exaggerated, but it's a little sharper on the left than it is on the right. And I've run into this before in problems I've given in calculus or even in college algebra, I've run into this function before. Anyway, well, let's talk about the domain and range. And now notice this dotted or dashed line, vertical line to the y-axis. What it means is that the graph will just come and approach it. It will never quite touch it. And so that's what's known as asymptotic behavior. This asymptote means that as the graph approaches this x equals 0, which is your axis, then the graph will sort of blend into it. It doesn't quite touch it ever, but it gets closer and closer and closer. Just gradually gets closer and closer without touching. So what is the domain? Now again, the domain is the set of all the x's, or all the input values to this function. And so the domain, and I'm going to expect you to write this in interval notation. It would be the x's in the interval from parentheses 0, positive infinity. So it doesn't touch the x-axis, I mean the y-axis rather. It doesn't touch where x equals to 0, so that's why I have parentheses here. Literally x is positive, is what the domain is. All the positive values for x. And it can be written this way. Now, when you write domain and range, don't forget to put the right variable, all right? If you tell me the domain is y instead of x, or if you just leave the variable off, then you're not going to get full credit. And so that's an important part of communicating accurately. Now, the range of this function is kind of open-ended, but it drops down to 1 and then goes up above. So here's the range. And, range, of course, is the set of all the output values. So all the outputs, all the y values, start at 1 and go up. So the range would be all the y's in the interval from bracket 1, infinity, parentheses. So here, because it dips down and touches at 1, my dot kind of indicates that. Then that tells us that we're including the points. So the range is y greater than or equal to 1 in this case. So, all right, well, there's two examples of this. Let me give you a third example where things are kind of split up.